I'm going to talk about a new raw material that is coming to the aquafeed industry pretty soon, we hope. And this raw material comes with a lot of benefits as well for the fish and for the environment. I will introduce per kilo, as it says here, local, novel, and scalable alternative in aquafeeds. It's called per kilo. So, the company going to do this, the name is BIO3. We are currently ready to build Norway's first large-scale facility for producing mycoprotein based on the per kilo fermentation technology. The technology has been developed and refined by Enifer in Finland. And it's something that started in the 70s, but has now been refined, and we are licensing this proven technology for our project. We're planning to scale it up to 100,000 tons. Is there a lot of echo here? Anyway, the ingredient is already EU approved for animal feed, and as such, it's ready to be implemented right away in fish feed. We are utilizing side streams and clean energy, and that will contribute to food and feed security and self-sufficiency in Norway, we think. So, a little bit about the volume. This initiative in itself will contribute, as it says over there, approximately 20% to the goal of the social mission of sustainable feed in Norway. And you can see it will also, you can compare it to approximately 50,000 soccer fields of soy protein production. And it contributes to a lot of more feed as is needed. And according to some industry experts, the only way of achieving something in the neighborhood of 50% self-sufficiency in this industry is to pursue fermentation technologies, to tap into side stream and from other industries and clean energy that we actually have a lot of in Norway. So looking at this timeline, you can see it started with this company already in 2015, after a lot of refinement coming from Finland. So it has been ongoing for a while already. And after several years of R&D, engineering, piloting, etc., we are now ready to begin construction of the phase 1 in 2025, this year. So we are ready, almost what they call ready to build, meaning it's construction ready. So we are ready. And we're going to have a commercial production of approximately 30,000 tons late 27. And while building this capacity, we're going to do all the engineering and refinement for the next phase, which is going to be 70,000 tons more at the same site. So altogether, a commercial production of 100,000 tons of this raw material in 2030. That's the plan. So we have a clear roadmap, and we're running as fast as we can. So what are we going to do? We are going to make an industrial symbiosis at the site at Averøya. If you see the top line here, that's our production. We take molasses and ammonia and a few other things like water and electricity, etc. We run continuous fermentation, make a protein soup, or the fermentation is actually 6 in the first stage. 6 big fermenters, continuous fermentation in the factory, make a protein soup, and then make it into a dried product. with approximately 65% protein. And then it goes into fish feed. But coming out of this factory, there's a few other side streams, like green CO2 that could be used in other fermentation to produce protein, for instance. The vinasse coming from the molasses will become vinasse coming out of the factory. That's going to go through a biogas facility where they produce biogas, obviously, but also fertilizer. And the waste heat is planned to go to a big greenhouse where they can produce thousands of tons of tomatoes and leafy greens. So it's going to be a complete symbiotic site here with other factories complementing what we are going to do. So why is per kilo good for the fish? It's a filamentous fungus derived from Pecilomyces varioti, that's the species. It delivers approximately 65% crude protein and can be adjusted a little bit up and down. And it has excellent digestibility, up to 89% has been proven. But it's not just protein. It includes health-promoting bioactives such as nucleotides, moss, beta-glucans, and others. So it's actually a functional ingredient for the aquaculture. In addition, using side streams from other industries and clean energy, it actually contributes to reduce the LCA of fish feed. Oh, this is not the slide I was expecting, but anyway. I think I need to move to this one. Anyway, there's been a lot of testing going on together with Foods of Norway, and it's been conducted by them. Trials with a control diet that you see on the left, and then 5, 10, and 20% addition of per kilo. Here you can see 2 plots stating nitrogen retention that is being improved, including more and more per kilo. And energy retention is approximately the same as a control diet, slightly better if you add up to 20% per kilo. But anyway, since the most important slide is missing here, I think all of this translate into improved FCR especially, but also a very good growth for the fish. I think I'll leave it to this since the real one is missing for some reason. But all of this with the nitrogen retention also indicates that all these functional, or at least some of them, of the functional ingredients are retained in the fish, so it can be utilized by the fish. So we're also involved in some ongoing research. For instance, a challenge study to test the effect on winter ulcers. And so far, I cannot tell you about the final results, but it seems very promising what we see right now. So it has a huge effect on those two, on winter ulcers, for instance. There's also ongoing field trial that we are involved in, kind of full scale. Starting now in August, so we are very excited to see what's happening there. And there's also results or test trials going on with other species. And there's more coming. We are planning ourselves to do much more R&D to document in full scale, actually. So, a few words about life cycle assessment and carbon footprint here. We've done some initial calculations. You see it on the right side there. It ends up at 1.08, And the main reason why it's pretty good is that we use molasses from other industries, the sugar industry, as the major or the main input, and also 100% clean energy to run our process. And we also send or put a low price side stream, the vinasse, to a biogas facility, and we recycle water and heat. So all in all, it looks pretty good. And we are still planning to improve for the next phase. The first phase, 30,000 tons, as I said, will look approximately like this, and then we expect it to improve a lot for the next phase, the next 70,000 tons. So, to summarize a little bit here, per kilo, as I said, is more than just a protein source. It's definitely a functional ingredient with demonstrated effects from several tests on immunity, gut health, and stress resilience in fish. It improves nutrient efficiency and reduces the need for additional feed additives. And it contains these bioactive compounds that I talked about. And as it's stated here, we know they are present, we know they work, and we know they add functional value to the feed. And as such, of course, we think it adds a financial value for the farmers. So, what we think, per kilo offers an opportunity to enhance the baseline level of functional ingredients in the feed while maintaining a very competitive cost. So actually, lower cost and healthier fish. That's our, how to put it, our strong value proposition. So that concludes my presentation. We think it represents a kind of a new generation of feed ingredients. It's local, sustainable, functional, and scalable in Norway. So we are very happy to collaborate with other partners in the industry to develop this further. So thank you for listening.
Many thanks. We have time for a quick question. No, I can't see any. You have one question?
Yeah.
Yep.
What do you think? Thank you for a very interesting presentation. What do you think will be like the main challenges when scaling up from a production of 30 to 100,000 tons? And then how do you plan on involving feed producers in that?
Yeah, that's a key question, of course. We need to collaborate with feed producers to make this happen. If no one is buying, then there's no project, to put it in simple terms. But you mean how to scale it, physical, how to do it? I can say we have the engineering, the basic engineering is done, and we are working on the efficiency of the next level factory already. And we do have the space for it. There's plenty of space to scale it even further from 100,000 tons as well. And there's space for other partners that could use the CO2 and hydrogen, for instance, to produce protein products as well from those side streams.